Hello and welcome to another Hasselblad webinar. Thank you for joining us today, wherever you are in the world. Today is another edition of our Phocus Q&A webinar, where you, the audience, get to ask questions when you register for the webinar and help to contribute to the topics that we cover during the session. I'm Mark Whitney, part of Hasselblad's European marketing team, and again, I'm joined by my colleague Chris Cooze, who is Hasselblad's Global Technical Communications Manager. Just before we go on and meet Chris and get on with today's webinar, just to go through the usual screens. So just to let everyone know that this webinar is being recorded and it will go up on the Hasselblad YouTube channel within a few hours of the webinar, or worst case by tomorrow morning. All of other Hasselblad webinars over the past year or so, 2 years, are on there as well. So if you've missed any, including the previous Phocus Q&A webinars, you can look back on there. And mentioning the previous Q&A webinars, obviously we've had 4 previous to today's, and these are the topics that we've covered in those webinars. So as I say, they're on the Hasselblad YouTube channel if you'd like to go back. If there's any topics there that we've covered that you would like to see, they're all archived on there. So for today's issue of the Phocus Q&A webinar, here's a brief agenda. So first of all, we're going to be looking at 14-bit versus 16-bit, and this is in terms of color. So what are the benefits of working with 16-bit files? We're going to try and give you some practical benefits of why you would want to work in 16-bit, as well as just glossing over the reasons or the differences between the two bit sizes. We've then got the highlights and shadows, local adjustments. We had a few questions on how to correct highlights and shadows in specific areas of an image. So that's combining the highlights and shadows tools with the local adjustments tool. And we're also going to recap on all the tools that are available in local adjustments. Again, the local adjustments is something that we've covered before, but Chris will just do a quick recap of the other tools whilst we're in that tool. Focus differences between the H system and X system. There's a few questions here that were relating to what differences would you see in focus if you were using an H system or an X system camera. So Chris is going to summarize generally what is the same and some of the small specifics that are different. And then also keyboard shortcuts. So Chris is going to go through a summary of the popular keyboard shortcuts within Focus. And we've also done a handy handout available for you to download. So if you look in the GoToWebinar control panel, you should see a handout section. And in there, you should see a PDF that you're able to download and keep, maybe stick it on the wall next to your computer and have it handy for when you're using Focus. So again, we're estimating it to be about 50 minutes, could be a bit shorter, could be a bit more. And it will leave a few minutes at the end, hopefully, for some Q&A. Please only ask questions relating to today's topics. If you have any other questions on Focus that we haven't covered as a topic, please save that for registering for another session in the future. So, hi, Chris, how are you?
Hi, Mark, good, thanks.
So I'm just going to try and pass over to you, the controls.
Thank you. So hopefully you should be able to see the presentation. So afternoon or possibly morning, everyone. So yeah, 5th Q&A. So we're going to make a little start and we're going to talk about bit depth basically and the benefits in terms of image processing, but we'll start discussing in terms of capture and then how that gets used within Focus and the pluses and minuses of that. So as a quick recap, obviously bit depth themselves, basically the sensor, it will have a particular bit depth associated with it, and when we move from the photons captured by each pixel, we need to convert that into a digital signal, and that will then go through an analog to digital converter. So for Hasselblad cameras, that is a 16-bit ADC. So in terms of, let's discuss in terms of levels per pixel, and we'll just keep it to grayscale or black and white at the moment before we move on to talking about color. So depending on the bit depth that your camera supports, if I take, let's say, the H6D100 that we've got in 16-bit mode, it is capable of discerning over 65,000 levels, or different levels on in that particular pixel. So we can't really just take this in isolation, though. We've got to look at the sensor itself, how much dynamic range it has, because that is then going to control how much of a range these levels are then going to be spread over. So bit depth is one thing, but we need to consider the actual dynamic range, etc., of the sensor in conjunction with just the bit depth. Okay. That's right. Computer playing up. Right. So for those, there we go. Sorry about that. The computer was not wanting to play today. So we talked there about grayscale levels or levels per pixel, but obviously with the imaging world that we're talking about, we need to talk about color. And so for each pixel, we will have 65,000 odd levels, red, green, and blue. So when you multiply that up for a 16-bit image, we're talking about over 280 trillion possible individual tonal values. Even down on an 8-bit file, we're talking 16.7 million colors, but obviously it ramps up very, very quickly as we move forward. Now, I've got an image here just to give us an idea. So the colored area at the back is visible images, a visible spectrum. And then the thing we need to look at is our gamut that we're going to be using. And that becomes quite important when we look at the next stage in terms of looking at color spaces and the number of bits that we've got and how we're going to deploy them. So if we look here, say sRGB, we've got this particular area here that we're going to deploy our bits over. Now, if we have a small number of bits, let's say 8 to 10 bits over a small color space area, not so much of a problem. But if we then deploy that 8 or 10 bits over maybe a wide gamut RGB, which is the yellow, you can see that there's going to be quite a distance between each of the tones that are possibly there that we're going to select. So we've got a much wider area that's spread over. Whereas if we're looking at, say, 16-bit, we have many, many more values that we can assign to this larger area. So that way, there won't be such a jump when I start editing my colors. As I move, maybe change, a density, a luminance correction, or even the color correction. As I shift, I won't run into too many problems. So just to bring these couple of bits together. So we're talking about, firstly, dynamic range. Secondly, the color gamut that we're going to be working with, and then the bit depth. So if I don't have much of a dynamic range on my sensor, and I've got a low bit depth, we're going to see the levels that the bit depth is spread over as discernible different values here, and we will see banding in the image or even posterization within the image. If we move to a high bit depth, but we still have a low dynamic range sensor, yes, we've got much smoother tonal transitions here, but we don't have the maximum and minimum values that we really want. Similarly, if we have a low bit depth, but we have a nice wide gamut, yes, we've got the saturated values top and bottom, but we don't have the dynamic range to spread that or we don't have the bit depth, sorry, to spread that across here. So the ideal combination, as we all know, to be honest, high bit depth and a wide gamut, a wide dynamic range from the sensor. That way, we get a very smooth transition through in terms of the tonal values from your brightest, most saturated value to white. So that way, with lots and lots of values, basically, if we have a wide color gamut we're trying to work with, good dynamic range from the sensor. And if you remember, 50 megapixel sensor from Hasselblad has 14 stops, and the 100 megapixel is 15 stops. So we've got a nice wide dynamic range there to work with. And that way, with the high bit depth into this color gamut, we've got a nice spread of the values across that color space. So, practical benefits of the higher bit depth. As we briefly alluded to, the size of your working space is then going to determine, if your bit depth is 8-bit compared to 16-bit, or even 12-bit compared to 16-bit. Your working space is going to control or specify how much difference there is as you start modifying, how much of a shift you might see. Will you see any banding? Will you see any posterization? So as an example, this top section here, the lighter area outside here is the Hasselblad L-Star RGB color space, and the colored area inside is the standard sRGB color space. So you can see here, if I only had a 10 or 12-bit bit depth in a small sRGB color space, no problem. But if I then have to stretch that over the L-Star RGB area, you can see there's going to be a huge amount more space between, if you like, the tonal values and points that are in that. Here, just as a representation, again, we have the L-Star color space, and this is against Hasselblad's RGB. This is Hasselblad's default working space. So even though HRGB is larger, much wider than sRGB, and in fact it's wider even than Adobe RGB, you can see that even here, the 16 bits applied to the L-Star RGB is going to give us much more flexibility in terms of image editing and tonal value recreation. So effectively then we're saying where the finest level of color and tonal reproduction is required, 16-bit files are required, or recommended, I should say, as opposed to required. They're recommended. Yes, it's nice to have the additional tonal points, but most importantly, it means you can accurately represent that particular, maybe a pigment in a painting, that type of thing. But also when you then edit the file, as you move values around to get them where you need, you've still got enough headroom within the bit depth to enable those tones to stay correct. Additionally, if you're shooting high dynamic range, which a lot of people do now, the higher bit depths and the wide dynamic range of the sensor working together mean that you can actually get away with capturing many less captures to create that still very wide dynamic range picture. I mean, you may even get away with 1 or 2 images to capture your particular scene, but generally at least 2, maybe 3, work them together. The actual higher bit depth and the dynamic range of the sensor work together to make life much easier, especially when you then come to edit them afterwards. Okay. So are there any downsides to bit depths or higher bit depths? Well, typically, if you have too small a bit depth, and then you start to edit the files massively, that can give you problems. So it's not really a limitation of high bit depth, but in this case, it's for too small a bit depth. So as an example here, this was a standard file, 8-bit, and then I went in and did a levels correction for the highlights to try and bring back some detail into the highlight area, brought the tonal value down, and then went back into levels, and you can see here we've got sort of combing effect, the posterization. If you were to zoom into the image, you can see the posterization. So we've got this comb style effect. So here basically is where there's missing data now, where we've done the adjustments. We just don't have the information between each of those levels to accurately represent it. 16-bit files, they are larger, so they will take up more space on the hard drive, media card, etc. That's just the way it is. Generally, let's be honest, storage these days is generally quite cheap, so it shouldn't really be an issue. Having said that, if you're not going to be using a wide gamut color space, you know, if you're not maybe shooting archival work or copy work, or if you do have some kind of constraints on what you can store, then there's nothing wrong with dropping down to 14-bit. And even if you're only going to be using, let's be honest, it maybe it's just a web job, which is only going to be ever shown in sRGB in 8-bit, then you could then work in a lower bit depth for that particular job. But generally, let's be honest, if you've got a 16-bit or a 14-bit camera, you're going to carry on shooting at that level and then modify the final image down to what's required afterwards. To try and work that into the system, effectively, the H6D does offer you the option to choose 14-bit or 16-bit, depending on what your requirement is, just to allow a little bit more flexibility in terms of storage options on when you're shooting in camera. So that is there. But I think in essence, what we're trying to say is generally the benefits of having 16 bits pretty much outweigh any of the negative sides in terms of file sizes and so on, especially if you're using wide gamut color spaces, you know, even Pro Photo, something like that. Nice wide gamut. So therefore, the more bits mean when you're editing, you don't start to run into problems. You know, probably we've all seen it when you're editing this lovely blue sky, nice smooth transitions through the sky. You start editing and suddenly you start seeing the posterization, the levels and banding to appear if you're not careful. 16-bit, I won't say that will eliminate that because you can always get issues pop up, but it just makes life that a little bit more easy. You won't run so much into those problems. I just want to touch on one final part, which is obviously with Hasselblad's X system and H6D50, the 50 megapixel unit, that the sensor that they have in the camera, obviously that has an output of 14-bit from the sensor, but Hasselblad then runs that through a 16-bit analog to digital converter. And we then transform that data and should we say, remap the values from the sensor into a full 16-bit color definition for the tones. And in certain cases, we actually transform values so that they would be outside of a 14-bit definition, so that it's actually a proper 16-bit value. Now, we've covered that in some detail in terms of the color management webinars and so on. So I'm not going to spend too much time or any more time talking about that, but just to say, we do have, even with the 50 megapixels, we do then transform our files into a full true 16-bit value. Okay. So before I move on to the local corrections and so on, Mark, is there any questions we need to deal with now, or can we do them at the end?
No, that's all good. Yeah, thank you. Good to move on.
Okay. Okay, so highlight and shadow, global and local. We've covered these to a great extent in terms of the global before, but just to a quick recap. So within the exposure tool in Focus, obviously there's the V3 is the default now, the algorithm. But as you know, V1 and V2, we talked about this recently, allow you to have different values. We'll just quickly recap that. So V1 and V2 pretty much are really in there for legacy purposes. So if you've got a file that, you know, a couple of years ago you processed in Phocus, you can bring it back in, and Phocus fully supports the corrections that you've done. And literally, if you just need to output it again as a particular file type, you can open up the old file and export it, no problem at all. Fully legacy supported there. Effectively, V2 improved the recovery and shadow and the clarity detail functions. And then version 3 added into that some improvements for contrast control, brightness control, plus tweaked what we'd done for the recovery and the shadow and clarity. So if you like, it's the latest incarnation of the algorithms. Now, bear in mind that even if you have, you know, from my old raw captures with my old H3D, I can bring them in. I can process them now either with the old legacy settings I had, or I can switch to V3 and use all the latest algorithms to actually extract even more detail through the system. So practical benefits, I think I'm going to show you this visually as we finish the PowerPoint presentation. It makes much more sense. But the thing to remember is there's no separate setting for the algorithm for whether you're doing local or global. You choose it once in terms of the version you want to work with, and that's it. The dynamic range then basically allows us to, with the latest algorithm, V3 especially, you can bring that highlight detail back without the graying effect as you get more and more, you know, towards 100%, or sorry, 100 correction value. You don't get that graying or color cast kicking in. You can also, with the shadow recovery, bring that back out, and you know, you're looking at least for the testing that I've done, 2 to 3 stops, no problem at all on shadow detail extraction before you start then bringing up, you know, if you go further and further and further, obviously it's going to get to a point where you're going to start sharpening up and opening up the noise that's in there at the darkest tonal levels. Again, the highlights, you can bring that back probably 4, maybe 5 stops is the testing that I've done in terms of the test files that I've got. I mean, you've seen in previous webinars some of my test files and how badly burnt out the highlight areas are, and yet we still managed to recover that. So what we're going to be looking at going forward here is the local correction of that, applying that and some of the other tools locally. So I think adjustment layers is where we're going to look at. We're always adding more tools to this adjustment layers section. So it's not just the recovery and shadow. Recently the defringe was added and so on. The actual application of that is where really like the retouching skill of the operator comes into it, in terms of is it a sort of half global correction, so you might use the radial or gradient correction, and I've got an image to show you that later, or are we looking at literally painting on correction for one particular area? And a good example for that would be a moire correction. So I've got an example of that to show you. The local corrections are not just limited to the adjustment layer. So if I go to color correction, we looked at in a previous webinar, effectively, you've got global and local within the single tool. So here we have a general overview, or correction, I should say, global correction for saturation, vibrancy. If I then use my picker tool, I can then select a particular color and its range, and then change its hue, saturation, and luminance values to affect a particular area. Okay. So we've covered that before. Okay, so quick summary of the benefits. The whole point is we do a general correction for a global image correction to start with. We get it where we want it, and there may be tones or areas where we need a little tweak, but a global isn't going to be good enough to do it, or it's going to affect too many other tones which will require correction. So there we have a small area that may need correction. It may be that we need multiple types of correction, so we can put multiple layers. So I may have an area which is burning out on a highlight, and I can adjust that. But also it may be a window that's in the side of a frame, let's say. So I've got maybe a burnt out net curtain, so I can bring back the highlights there. But I then may have a color shift of the daylight coming through the window compared to the warm light inside. Maybe it's too much. So again, I can add another adjustment layer and modify the tint and temperature to bring that back into a more pleasing look. The moire correction I sort of suggested a few minutes ago is a classic example where you may have a particular area in an image which is showing that moire interference pattern. But to use the global moire tool may then try to correct what the system thinks is interference patterns elsewhere, and it may not be. They may not be showing anything until you then try and do a global correction, and it actually adds a correction where it's not required. So this again is another place where the local correction allows you to go in, paint on into the area you need, and then adjust the correction accordingly. But I'll show you this in terms of a live focus demonstration in a few moments, because that's the easiest way to see this. Okay, so talking here about comparison for HNX system when using Phocus. Now, when we looked at this, it was easier to start with to talk about the main similarities. Effectively, Phocus will allow you to process files from pretty much the CF digital back onwards, H2Ds, H5Ds, H6Ds, pretty much everything, CCD and CMOS sensors. The system will open 3FR files and 3F files and allow you to process, edit, and export. So pretty much the whole raft of files. It makes no difference really to Phocus what camera they've come from, and it's designed to give you, should we say, a matching result. And again, even an early CFH file or early CFE digital backs, the files from there can still use the latest algorithms so that we can extract even more detail than was possibly available in earlier versions. Additionally, CMOS and CCD sensors, the calibrations in the system and through Phocus mean that I won't say it'd be 100% impossible to see a difference, but you would have to be pixel peeping and checking. They're designed to give you the same output, regardless of whether you're using a CCD or a CMOS in terms of the color and quality. In general, I think we can say that the vast majority of tools are exactly the same. They work, it's camera non-specific. Even down to things like lens corrections. So we can see here, I've got a 503 with a Zeiss lens on it and a CFE 50C2 back. Here we can then use the camera and the shutter, and the back just works. And the lens corrections within Phocus will be applied. You'll obviously have to tell it. In this case, I was using maybe an 80mm or 150mm, whatever you were using, and Phocus will apply that correction from a manual list that's available. Still supports Firewire, USB tethering, no problems at all. So that's the similarities. Now we're going to talk about the differences. This is the main point. And when we check through, most of the differences occur when you've tethered the cameras. If a H camera or a X camera, let's say, the difference are fundamental between them in terms of the connection. So looking at some specifics, there are certain tools within Phocus that enable certain parts of the functionality. So for instance, as a H camera, the focus bracketing function cannot be used with the camera as standalone. By using Phocus tethered to the camera, it enables us to switch on some of that focus bracketing functionality and deploy it. Now, there are some limitations. For instance, with a H body tethered to Phocus, we can't use the specify limits, but we can use the rest. Okay. Interestingly, if you there's some testing going on to see if you can actually use H lenses with an X camera with the specify limits without any issue. So hopefully that'll be test will come back from that for you. But at the moment with the H body, you can't use the specify limits. But at least we've now got focus bracketing by deploying Phocus through tethering. There are also some other specific differences. So obviously if I'm using a CCD based camera, obviously this is going to be most H camera, then because of the CCD chip and the way it works, your live view is black and white and it has a much slower refresh rate. One frame is sort of 5 or 6 seconds basically. Whereas cameras with the CMOS sensors color live view and the full 30 frames per second. So again, this is hardware differences. We looked at HTS in a recent webinar, but basically full implementation is achieved on the H system. So with this, any modifications you make to the tilt, the shift, the rotation angle of the HTS adapter is shown fully on the camera. So on the actual grip display, you can see, in the digital back, you can see exactly what corrections you've made. And just as importantly, it's embedded into the raw file in terms of that data and the fact that you were using a HTS. That is then used to create a specific lens correction when the file is processed in Phocus. You can attach that HTS to an X camera, or a 907X in this case, or an X1D2, sorry. But the actual adjustments that you're making to the HTS, they're not recorded. So the camera doesn't see them, they're not recorded into the raw file. And because of that, none of that data is available to Phocus to generate a specific lens correction based on the tilt shift corrections that you're using. So it will just see, in this case, it would be a 24 or 28mm lens, and obviously the 0.8 converter is what will be seen and a correction made for that. Obviously, H system able to use the CF adapter. So I can then put a V system lens on here, and obviously the CF adapter allows you to recock the shutter. The benefit there is I can then use the shutter in there for flash sync. I don't need to use electronic shutter. Within Phocus, when I'm processing the files, I can then select, yes, I was using an 80mm lens, V system 80mm lens at this aperture, this distance, and the system will then generate a lens correction based on that information. So fully integrated there, even with the adapters that you're using. So I think we can sum it up that Phocus itself will allow us to extract some additional functionality from the camera bodies. As I said, with the H system, it allowed us to then access the focus bracketing functionality with some limitations, obviously. And to a certain extent, that allows us to push the camera platforms to do as much as possible. But obviously, there comes a point where the actual camera platform limits what we can do in terms of the functionality and expanding that. So that then becomes the limiting factor. Not just a case of we haven't implemented it in Phocus, it's the camera hardware becomes that limiting factor in terms of processing what we need to do, etc. Okay. Any questions on that one, Mark? Nope.
Not on this particular subject. We've
Cool.
got some on the other topics, but we'll come to those, shall we, at the end?
Yeah. Okay, we'll do that. Fine.
Yeah, thank you.
Phocus shortcuts. Now, this is a little bit of a difficult one to, shall we say, cover on on a webinar, but I just want to run through the main ones that you're going to run into that I tend to use most of the time, that are useful. And don't forget, there's also a lot of the shortcuts that will work on this particular platform that you probably use for other applications. So, the control C, control V, that type of thing, control X, all of those functions allow us to work in the same way within Phocus, which we'll look at in a moment. But looking at this, new capture, export, the zoom functionality, pretty quick and easy to remember these basic ones. I think from a tools point of view, these ones are also, I would say, I use on a regular basis in terms of accessing the tools generally that are under the main viewer window. So it will be, the hand tool, the neutralization tool, etc. And then obviously zooming in, zooming out. A couple that I get asked about quite often is for the grid and the overlay. Now, no issues generally for switching them on, whether you're using the keyboard or whether you're using the actual button press. But I get a lot of questions from people: how do I move the grid? How do I move the overlay once I've got it in there? And you've got to look for that one. But basically, it'll be Alt or Option key, depending on which platform you are, and then holding those keys. Once the grid is switched on, once the overlay is showing, you can then move it around to the area of the image that you want. And that's actually some of the most useful shortcuts that we've got there. So we'll show you some of those in the live operation, but I think we need to move to Phocus now to go through the local adjustments and so on before we do the rest. Okay. So hopefully now you should see Phocus. And what I'm going to do is just bring up the adjustment layers. And I'm going to just select a file. Okay, here's a classic one. In terms of values, we can see here, we've got a much brighter side to the image. And in fact, if I move my cursor there, you can see it's almost burnt out, 255, 255, 254 in terms of RGB values. So very bright there compared to over here, down in the 170s. So in this case, it's no good me doing a global correction, so I need to apply an adjustment layer. In this case, it's going to be a highlight recovery. So I'm just going to apply a small amount. And then so I can see what I'm doing, I'm going to enable the color toning of the area I'm correcting. Now, because it's such a large area, I'm going to choose the gradient tool. And I'm just going to drag across the area. You can see there's a good feather there. We can try that. Untick the area, and you can see now that the values here are much lower. But I also have, if I turn off the tool, a smooth transition. I've not got a line. So even though that's a local correction, I've managed to carry out or correct a larger area here. Normally, when you're using the local tools, you probably would be working at a much smaller level. Okay. Okay, so this is a particularly poorly exposed shot, and you'll have to believe me when I say it was taken specifically, but effectively here we have got a burnt out sky, and you can see RGB values, it's 255 maxed out all the way up pretty much to the top here, and then we've got some deep shadows here. We could try a general correction here, and in fact I will try that for you. So I'm going to brighten up a little bit on the image, try some shadow correction, and we're bringing out the detail in the windows here, but obviously we're now maxed out here. I could try a general correction like that. If I go to 100 to show you the worst case, I mean, it's okay, it's bringing some detail back, but it is affecting all the highlights in the image. So in this case, I would probably limit it, whoops, to something like that. And then again, I would apply a layer. And in this case, then I would paint this section to try to bring back the values I need. So if I just put on 50%, shall we say, switch it on, and then this time I'm going to use the brush tool, and down here you've got size, flow rate, and most importantly the feather. So you can see the size there, and generally I would zoom in, and then I can paint as nicely as I can. I believe you would take a little bit more time. I am quickly doing this as time is going to be against us today. Okay. I can assure you that you would take much more time over that. Okay, just for a very quick display. Now I've got a very hard line there, so I'm now going to then drag that back, and probably what I will end up doing is correcting the area. There we go, very quick and dirty. And then, but the whole point is that I can tailor my correction to the small areas that need fine tuning. And it would be much better, obviously, if you spent more time. And now I can then tweak that correction to the level I need without affecting the highlights on the rest of the image. Simple as that. Okay. If I move to this particular image, I think we can see here that we've got both ends of the extremes. So again, I would be looking to do probably a shadow recovery as best I can. Whoops. There we go. And then again, probably rather than try and do anything with the sky, I would again paste a highlight correction here to bring the stone down to the level that I want. So again, you can apply multiple layers. So if I was to apply a shadow correction, let's say, and again, we'll use the brush, I can literally apply this, and please note I am rushing I would normally spend a lot more time in terms of placement. And again, if you press the option keys, you can take off what you've put on. And now I can open up that particular window in terms of its tonal values. Good. Then apply another layer and apply either a highlight correction or a color correction or whatever I want, and just keep building up the local corrections. So in this case, ooh, maybe a little bit too big. I could just drop these tones down very quickly. Simple as that. And again, I can add another layer, multiple layers to then tweak areas of the image that I want. And then it's easy to go back afterwards and think, actually, no, I didn't want that. Switch it off, switch it on, and then go back and modify. So just like layers in Photoshop, no problem there at all. Okay. Probably one of the most useful local corrections that I've run into would be something like moire. So if I just switch that off. Now, to see this, you need to go to obviously 100%. And if I move this around, you can see it's quite bad here. And generally, you would go to the noise filter and you would apply the moire correction here, which would then correct the image, but it would do it in a global way. So maybe need to go to 4. Yep. So then if I hold the space bar down, I can move the image around and just check that it's pretty much corrected the whole image. No problem at all there. Now, in this case, it's fine, but there may be, other materials or detailed areas here that aren't showing an interference pattern. When I apply a global correction, it will try to effectively soften off the detail, the interference as it sees it in that area. So in that particular case, the global tool will be no good. We're just moving the problem from one area to another. So in that particular case, we would then move to using a layer. Okay. And here we have the moire tool. So I'm going to put it back up to roughly the same area, or the setting that we had. And again, here it's up to you. It could be a case of you want to apply it with a radial filter or a linear tool, or maybe just a brush. So as an example here, I think we need to pop down the size. I'm just going to paint this correction across here so you can see it. And it disappears. So you can see it's fine tunable to the particular area that you want. And obviously if you turn on the color, you can then see exactly where you are correcting. And switch off. And then you can adjust the actual correction level to what you need. So that, in a nutshell, is the benefit of that local correction. You can put multiple corrections into multiple areas, fine tune all of that data back to where you want it. Okay, you've got some questions, Mark.
Yeah, just a quick question on local adjustments from Christos. Is it possible to paint out areas of a radial or gradient mask?
Yeah, so if I just quickly go back to the image that I applied that gradient to. So we can see here that I applied effectively a recovery correction to this image. And if I switch on, you can see it was applied here. Yeah. So what I could do is if you then apply another layer, and I mean the simplest way would be to just switch that on so you can see what I'm doing. Do a negative recovery. Let me just push the brush size up, Mark, sorry. So you can see exactly what I'm doing. And I'll do it rough and ready just so you can see where it stands out to see that we've actually done it. Cool. All right, so basically you can apply a negative of what you applied to bring that level back up. That's no problem. So this, you can see it's back up to 255 where it was originally. Alternatively, if you wanted to, if I just go to the top of this and close, so we've got a bit more space, I can go back to my original layer, and then you can see here I've got a plus because I'm on the brush tool now. Even though I applied a gradient, I can switch to the brush tool. If I then hold the Option key, I can fine tune where that's applied. Okay, but normally I find it much quicker, much easier to effectively split the layers up. So if I've done a gradient or a radial fill, I would then go, okay, yes, but I've gone too far over here and I need to get back in, then apply a second layer and just tweak it with the brush because you can be much finer. That makes sense?
Yeah, that's great. Thank you. Hope that answered your question, Christos. Couple of questions going back to the 16-bit, 14-bit.
Yep.
Ken is asking, is the 16-bit conversion for, so you mentioned about obviously the 50 megapixel sensor, say in the X1D2 converts to 16-bit. Does it still do that if you use another photo editor like Lightroom, or is it done in Focus?
It's Focus.
Right. Okay. So that would be another benefit of using Focus then, I guess.
Yeah. Yeah.
Okay.
Very much so. I mean, obviously, when the images come through from the camera, so let's just say we're going to go to, let's say Lightroom, or even through Camera Raw into maybe Photoshop, there is a conversion that takes place there, and it's pretty good. But the whole point to as we've covered in the webinars before, to keep within the Hasselblad color space and actually use our Hasselblad RGB color space, it has to go through Focus for those transformations and remappings to take place.
Yeah, I suppose you have to see Focus as like an extension of the camera. Yep. It's it's a vital part of the workflow. Yep. That's why we give that's why Focus is available free. If you buy the camera, obviously it's part of the camera. Yeah,
correct. I mean, that's why through the color management presentations that we've done, we have always suggested that you should process your raw in Focus, not maybe to the finest level that you want, but to get the lens corrections, to get the color conversions, and then export it with the color profile set to source, and that then embeds the Hasselblad RGB. So then when you open it in Lightroom, or if you open it in Photoshop, you'll get the message saying your working space is Hasselblad RGB. Are you sure you want to use that? You say yes, and that way you stay within the Hasselblad color space.
Yep. Okay, and we just had a question on that as you were answering that, so that's all good. Okay, and a question from James. Is there much point in working in 16-bit files when you're printing images? So, for example, if your print lab isn't able to support 16-bit files?
Yes, there is. Basically, whether it's 14-bit or 16-bit, you've got a lot of bits there. And yes, most, if you're talking maybe about silver halide type printers where it may be 8 or 10-bit maximum, there is obviously going to be a loss of some of that tonal value. But as we've covered before, if you've got the information there, when you then edit the image to get it how you want it and looking in your computer, you are then in full control of how that image is then transformed for output. So you can actually choose the conversion, whether in Photoshop we talked about whether it's perceptual rendering or whether it's relative colorimetric. So you can have more control of that, how it's downgraded to be converted for, even going to sRGB. There's a compressing and throwing away of information, but you're in control. If it's not there, obviously you can't put it back. So it's better to have it, and then you're in control of moving it down to what you want and then getting rid of it.
Okay, great. Thank you very much, Chris. I think that pretty much brings us to the end of today's session.
Okay.
Yeah, so thanks for that, and thanks again for everyone joining and your contributions for the topics that we should cover. I hope it's answered some questions for you. So just to finish off, as usual, if you could be so kind as to help feedback what you thought of today's webinar. It's always good for us to know what we're doing well and what we're not doing so well, so that we can try and make things better for future webinars. So that's much appreciated if you could just spare a couple of minutes to fill that in for us. As another reminder, this webinar is being recorded, so it should be up on the Hasselblad YouTube page, worst case by tomorrow morning. So you'll be able to watch it back, and also all of Hasselblad's previous webinars over the last 18 months, 2 years are also on there as well. So if you've missed any or not joined us before, please have a look back on there. And then just to finish off, for any more information on Hasselblad, of course, hasselblad.com, our website, everything on there from future webinars like this one and physical events, lots on our products, our partner network around the world, lots of inspirational stories and images that you can read and look at, lots on our history, and you can also request a demo from your local Hasselblad partner and ask for any support that you may need. So thank you very much again, and hopefully look forward to welcoming you to another Hasselblad webinar soon. Thank you.
Thank you.